So let's start question 1. A 1,500 kilogram car is traveling west. Okay, so it's this one. At 20 meters per second on a horizontal frictionless track. It collides with a 2,600 kilogram truck traveling at 16 meters per second east. After the collision, the car travels at 5,2 meters per second east. See the diagram below. Guys, so before we answer any question, what is always your first step in this type of momentum problems? Choose direction. Yes. So they didn't state for me which side is positive. So you must always choose your direction before you can continue. It's very important. So for me, I always like to take east as your positive direction because it's that way. Okay. So we take east as your positive direction, and now we can start to do the first question, 4.1. So state the principle of linear momentum in words. Do you have a question? Are you still writing down? Okay. So the principle of conservation of linear momentum in words. So guys, what's the principle of momentum? Momentum in a closed system always stays constant. Okay, it is conserved. So momentum, linear momentum in a closed system is conserved. So what does that mean? Total momentum before the collision is the same as your total momentum after your collision. Let's look at your next question. Calculate the velocity of the truck immediately after they collided. Okay, so what are we going to do now? Now we start with our principle first. Nee. So we say the total momentum before the collision. It's so important, this step, guys. You must always start with this, okay? Total momentum after the collision. Okay, now what is the total momentum before collision? Can you remember what's the momentum's formula? Can you remember? Yes, I want to hear it. P equals mv. Yes. So now we state that the mass of the car and the initial velocity of the car plus the mass of the truck and initial velocity of the truck equals still the same mass of your car, the final velocity of your car, plus the mass of your truck and the final velocity of your truck. And this is then your first step to determine your final velocity of the truck. See, the mass of the car is 1,500 kilos, okay? 1,500. What's your initial velocity of the car? The initial velocity of the car is 20 meters per second west. Nee. Yes. So it is then minus 20. Good. Because you choose direction. Okay. It's so important. Plus the mass of the truck will be 2,600. And your initial velocity of the truck is 16 meters per second east, and that is my positive direction there. Okay, guys, I'm just going to continue here with the rest of the formula. The mass of the car on this side is still the same. It's 1,500. What is the final velocity of the car after it collides? 5,2 meters per second. But can you see the car actually changed direction? Nee. It was traveling to the west and now it's traveling east. It makes sense for you, nee? Because if you collide in a truck the car will take the truck's momentum actually when in his moving direction. Makes sense, no? Okay. So then it's 5,2 plus 2,600. And the final velocity here is the unknown I'm looking for. Okay. So now, guys, you take your calculator and you determine, just do the left side first. There's no unknowns there, so you can get a value, and then you do the right side. And the V final, I get 2,600. Do you get 1,4615? So it will just be 1,46 meters per second. And now, guys, can you see you get a positive? And this positive value actually means something. It means that your final velocity of your truck is still in the east direction. But can you see his velocity actually decreased? Okay. So 1,46 meters per second east. Okay. Now, guys, can you remember what's the meaning of an elastic and an inelastic collision? Well, the what is the same? The, yes, your kinetic energy is the same. So that's important that when a collision is elastic, did the kinetic energy become less after the collision? No. So the kinetic energy before the collision is the same as the kinetic energy after the collision. So elastic and inelastic is all about your kinetic energy. Guys, can you remember what's kinetic energy's formula? Half mv squared. But now it's important to note that you must take the whole kinetic energy before the collision. So we have the car's kinetic energy and the truck's kinetic energy. Okay, so now how are we going to formulate this question? So you say for a collision to be elastic, the total energy, so we do this, kinetic energy before the collision must be equal to the sum of the kinetic energy, the kinetic energy after the collision. Okay, now I just do it the same as the momentum. Now I just count them together. So let's see. Kinetic energy is half mv squared. For what is this? This will be for the car, plus half mv squared. For what is this? For the truck. And then I just do the same. Half mv final squared for the car, plus half mv final squared for the truck. Sorry, I can only fit in a t there. Okay, so now let's quickly fill in your values. I have a half of 1,500. The initial velocity for the car, you will see it won't make a difference if you substitute a minus or a positive because you square it and then it becomes always a positive. Okay, but you can still just fill in your minus 20, just that you know. Okay, squared plus a half of your mass of your truck will be 2,600. And this is then the velocity is 16 squared. So guys, please work out this value first, and then we will see if it equals this value. Okay, so what's your answer on this? This answer is then 632, nee, or 23. Like this, 800 joules, nee. Okay, so this was your answer for the kinetic energy before. So I'm just running out of space. I'm just doing this now underneath here. Okay, let's do the after one. So the kinetic energy after will be half m of the car final velocity squared of the car plus half m of the truck final velocity squared of the truck. Okay, that will be a half 1500. Final velocity of the car was 5,2 squared plus a half of 2600. Final velocity of the truck was 1,46 squared. And then what's the answer you get there? 23 joules, okay, so it's comma 1 then, No, let's leave it comma 0.8, it's fine. Okay, joules. Okay, so what can I see, guys? The kinetic energy before is not the same. Please use this equation to show it, okay? Is not the same as the kinetic energy after, and then this is also important, therefore, inelastic collision. Then 4.4, which one of the vehicles will experience a greater amount of damage during the collision? Now you must explain your answer. So what are you guys thinking? Which one, the car or the truck, will experience the more damage? Yes, the car. But why? Why in physics? How will you explain that? More mass, more power, force, But the thing is that he will change direction and he will change his acceleration more quicker than the truck, faster. So that means that the impulse actually will be much larger on your car. Okay, so the damage will be more. So the thing is, he will change direction and he will change velocity much faster than the truck. And if you change velocity much faster, then the damage will be much bigger. Okay, because the force is also much bigger on the car. Okay, so you can say the car will experience more damage. And then you can say change in acceleration or in velocity faster. Start. A ball P with a mass M is initially rolling eastwards, okay? When it collides with the identical ball Q. Okay, this is P. I don't have his mass, it's just M, and he's rolling eastwards. Okay. When it collides with the identical ball Q, also then it's identical, so it must also have a mass M. Rolling westwards, like this. Ooh, yeah. Okay, that's fine. Westwards, and this is actually a velocity of 15 meters per second. Okay? Ignore the rotation effects on the balls and friction. The graph below shows how the velocity of ball P changes with time. Guys, please read your answer more than once because this is your graph for P. But they never tell it for you in your headings or anywhere here. They just tell you here, this is the graph of P. Okay. So now let's first do 3.1. Define the term impulse in words. Can you remember what is impulse? Now, impulse is the product of the net force and the time the force acts on the object. Can you remember the formula of impulse? F net times delta T equals impulse. But now, guys, can you also remember what impulse is also equal to? The change in momentum. Yes. It's just that you take note, because I think we are going to use this. So impulse is also the change in momentum. So therefore, F net delta T equals delta P. You don't have to write this down. They only ask for the definition. But I just want you guys to think a bit about what we talked about when we learned about impulse. It's also the change in momentum. Now, guys, we must calculate the velocity of ball Q after the collision. Okay. So then I do the same. Let's start with the sum of momentum before equals the sum of momentum after the collision. So we have the mass of P, the velocity of P, plus the mass of Q and the initial velocity of Q. Then we have our mass of P, final velocity of P, plus mass of Q, final velocity Q. So the mass of P is m. What is our initial velocity for P? Can you see that it is 10 meters per second there? Ne? So ball P is rolling eastwards. We can say east is positive. Can you see that this was the graph for P? So we can say that initial velocity of P is then 10 meters per second. Can you see that on the graph? Okay. Okay, so we have only m and then we have times 10 and it's positive, okay? Plus again m, and what is the initial velocity of Q? It was minus 15. Nee. Then I have m again. What's my final velocity of P? Guys, now you use your graph. So let's see in what increments is this divided in. So we have 1, 2, 3, 4, 5 lines, and it's in minus 10. So it's minus 2, minus 4, minus 6. So this line here is minus 6. And can you see this was the time the collisions was, okay, so this was his initial velocity 10, and then it collides, and then it's on his final velocity of minus 6. And then I still have m, and then this is the one I want to work out. VF final for Q. Okay, just to quickly repeat, you get minus 6 on this side, you take it over, you get plus 1m equals mv final Q, and your final velocity is 1 meter per second east. Let's record this. It's observed that the kinetic energy of the system decreases by 28,8 joules. So how will you do that? How will you state your problem or your formula when the kinetic energy decreases? So your energy is actually released. Nee. Okay, so can you see that you must write it like this? Kinetic energy before. So the kinetic energy decreases with that amount of joules. So then it's kinetic energy after, and then it released 28,8 joules. So we will say kinetic energy before. So what will that be? A half m for P, V initial for P squared, plus a half of mq V initial q squared. So let's just do the before one, and then we get an answer. So the mass of P we must determine, because it's exactly the same as the mass of Q now. So it's a half m, and then what's my initial velocity for P? It was 10 meters per second, né? Squared, a half m, and then the initial velocity for Q was, because the square will be the same answer. Okay. So guys, what do you get there? Let's see, a half m 10 squared plus a half m minus 15 squared. Okay, now we are doing the after. So we say 162,5 m, and then we do the after equals a half m for P, so it's m, V final squared plus a half m for Q, which is also just m, V final squared. And then we plus the 28,8. Okay, then it will be, what's the final for P? It was minus 6, ne? So it was m minus 6 squared divided by 2 plus m. The final velocity for Q, then it is 1 squared divided by 2, and that's plus 28,8. Okay, guys, can you get me an answer for the right side? Guys, so you take your 162,5 m minus 18,5 m. So 144 m equals 28,8, and then I just divide by 28. No, sorry, then I divided 28,8 with 144. And I get the mass as 0,2 kilograms. Let's quickly just work out, because they ask which one of these three vectors represent the resultant of the two. Now, it's not necessarily the change in the momentum. We must just first work it out, okay? We have momentum initial. What is it? Mass times velocity for P. Okay, so this is for P, initial velocity. So what's the mass of P? It was 0,2, and our initial velocity for P was 10, ne? So what was this answer? It was 5 meters per second. No, kilogram meters per second, sorry. Kilograms meters per second minus 1. What's my final momentum? It's still 0,2. What is the final velocity for P? Can you remember? It was minus 6. Yes, minus 6. So this is then 0,2 times. Okay, so this is also then kilograms meters per second. And now what is the change in momentum for P? So that will be the mass, final velocity minus initial velocity. So it will be 0,2, final velocity will be minus 6, initial velocity will be minus 10. So minus 6 minus 10 will be minus 16, and 0,2 times minus 16, negative 3,2, and that's also kilograms meters per second. Guys, now they want to know, so each of this is a vector. So now they want to know which one of this is the resultant. So now you just quickly go and draw a diagram, just a simple one. So we have the initial momentum as 5, kilogram meters per second, and this is the positive value, so it's east. Then we have the final momentum as minus 1,2. The change in momentum is minus 3,2. So when I have the axis, let me just show you quickly. So let's just quickly go back to 3.3.2. Guys, what is the magnitude of the net force? Can you remember? F net times delta T. This is your impulse, né? But it's also the same as the change in momentum. So I want F net. So how do I get that? I get the change in momentum over the change in time. And they ask for P. So we have M, V final minus V initial over delta time. So the mass is 0,2. What's the final for P? It was minus 6, né? And then minus the 10 over, then you must go to the graph and see the time increments there. Guys, just see the time, né? You take the time in the collision period here. So it's this time here minus this time here. Okay. So you must just work it out on your graph. What's that time increment? And then you get an answer of minus 6,4 Newton. So what is this minus means? It is in the direction of west, né? F net equals 6,4 newtons west.